Welcome to Mathematics and Statistics, Class 12, Matrices. This is the second part of the series, Mastering with PYK. Let's start by solving 2.1 and understanding the concepts. Question number 2 says, classify the following matrices as a row matrix, column matrix, square matrix, diagonal, or a triangular matrix. So these are all the types of the matrices which we have seen in the earlier sessions. Now, to understand a triangular matrix condition, a triangular matrix has to be a square matrix. So first we have to understand whether it is a square matrix or not. It can be a upper triangular or a lower triangular. Upper triangular if all the elements below the triangle is 0, and lower triangular if all the elements above the triangle is 0. So in this example, we see that all the elements above the triangle and all the elements below the triangle. Right? So we start with identifying whether it is a square matrix or not. Yes, this is an order of 3 by 3 matrix, so it is a square matrix. Lower triangular elements are 0, right? Therefore, the given matrix is a upper triangular matrix. Question number 2 of exercise 2.1. We have been given a matrix. So first we'll identify the row and the column. So order of the matrix. So order of the matrix says we have 3 rows and 1 column, right? So we have 1, 2 and 3 row and the column is 1. Therefore, the given matrix is of a column type. Question number 3. We'll start with order of the matrix. We have only 1 row and 1, 2 and 3 columns. So the order of the matrix is 1 cross 3. Therefore, the given matrix is of type which is called as row matrix. Question number 4. Order of the matrix is to be identified first. So order of the matrix is 2 by 2. So it is a square matrix. Non-diagonal elements are 0 and diagonal elements are equal, right? Therefore, the given matrix is a diagonal type and a scalar type. Question number 5. We studied about the triangular matrix. So let's revise the conditions again. The matrix has to be a square matrix. It can be upper triangular or a lower triangular. Upper triangular if all the elements below the triangle is 0 and lower triangular if all the elements above the triangle are 0. So in the given matrix, first the order of the matrix which is 3 cross 3, that is 3 rows and 3 columns. Right, now it is easy to identify, I guess. These are 3 columns and we have 3 rows. So it is a square matrix. Upper triangle elements are 0. Therefore, the given matrix is lower triangular type. Question number 6. Order of the matrix has to be identified first. So it is a square matrix 3 by 3. Non-diagonal elements are 0. Diagonal elements are not equal and not 1. So it is only a matrix which is a diagonal type. Question number 7. Order of the matrix is 3 cross 3. It is a square matrix. Non-diagonal elements are 0. Diagonal elements are equal to 1. Therefore, the given matrix is of unitary type or a identity type. So it is a diagonal matrix with the elements in diagonal as 1. So it is known as identity matrix. Let's understand few concepts. Symmetric matrix. A symmetric matrix always has to be a square matrix. Assuming A is a matrix which is denoted by Aij, of rows n and column n. Since it is a symmetric matrix, the rows and columns would be same. If Aij is equal to Aji, this means your rows and the columns get interchanged for all I and j, right? Then the matrix becomes a symmetric matrix. So in this example, this is a matrix. Say this is a matrix A, right? Always denoted by capital A. This is of order 2 by 2. So it is a square matrix. Now let's understand A11. A11 is this element, right? Which is equal to A11, which is equal to minus 2. Why? Because I is 1, j is 1. So when we interchange, it becomes 1, 1. A12 would become A21. So both the elements are 3. So they are 3. And A22 is equal to A22, which is 8. So this is an example of symmetric matrix. Now properties of the symmetric matrix. If A is equal to A transpose, then the matrix is a symmetric matrix. This means when we are able to put the elements of A in A transpose and both are equal, then it is a symmetric matrix. A null matrix is a symmetric matrix. So example, this will be an objective question. Is null matrix a symmetric matrix? Then yes. If A transpose is negative of the original matrix or the original matrix is negative of A transpose, then it is called as a skew matrix. It is called as a skew symmetric matrix. So even null matrix is a skew symmetric matrix. Equality matrix. When a matrix A and B are such that Aij and Bij are the elements are same and the order is also same, right? They are equal if Aij and Bij for all Aij are equal, and we call it as order of the matrix A has to be equal to order of matrix B. Equality can exist or can be defined only when the orders are same. Example, here A is a matrix of order 2 cross 3. This means 2 rows and 3 columns, and B is of the order 3 by 2. Are these matrices equal? No, because the order itself is incorrect, so these matrices are not equal. Also, the property of addition and subtraction also says that the order is important, so order has to be checked before the operation is defined. Now let's take an example. We have to find A and B variable in the equation, and it is given that matrix A is equal to matrix B. So how do we start? We start with the order of a matrix. So if the order of matrix A is equal to order of matrix B, then the equality exists, right? Given matrix A is equal to matrix B. This means the first element of matrix A will be equal to first element of matrix B. Similarly, the second element of matrix A, that is A12, first row, second column would be equal to first row, second column of matrix B. So we know that 4 and 4 are same. Similarly, here A21 is equal to B21, right? And therefore, this and this also has to be equal, given that both the matrices are equal. Then, right? So A12 is equal to B12, which is 4. So on solving, we get 2a minus b is 1 and a plus 2b is equal to 2. On solving this, we get a is equal to 2 minus 3b, right? So we multiply this by 2 on subtracting, right? We get it as, on subtracting, this will become minus 7b is equal to minus minus 3. So 7b is minus 7b is minus 3. So b is 3 by 7. Now putting this in this equation, we get A is equal to 5 by 7. Right? So if the matrices are equal, the terms of both the matrices are equal. So if matrix A is equal to matrix B, then Aij of the matrix A will be equal to Bij for all I and j. And it is vice versa also. You can say that B is equal to Aij for all the elements of I and j. See you in the next part. Keep practicing. Success is possible. How? By practicing and practicing. Keep practicing. Bye-bye.